Hello, and welcome to 3.6. This one's going to be off the chain rule. This is something that is very important. It is very useful and one that is only this for the entire section. So it's short and sweet, but again, you got to make sure that you really comprehend what we're doing here because it in by no means is easy. We talked about many different techniques through the first 5 sections of this, but now we're going to be talking about functions that have what are called a composition. One function is made up of another. So we call these compositions, and we could try to use all the limit rules and derivative rules to try to break this up and extract one from another and then evaluate that point. But we're looking for easier ways, not more complicated. And so you got to understand that this is actually an easier way than an alternative. So keep that in mind because I know it does seem a little weird. And the name of it is obviously called the chain rule. And the reason it's called the chain rule is because of the connectivity of one function within another. All right, so let's go over the one and only definition for this section, Theorem 361, that says if we have some function g that is differentiable at some value or all values of x, and f, another function, is differentiable at all of those outputs for g of x, then that composite function, which we're going to call h of x, which is just g within f, easier written and seen this way, then it is differentiable, and we can find the derivative of this composite function by doing this. The derivative of the outside function without touching the inside function, we're only doing one derivative at a time, and then multiplied by the inside function's derivative. So yes, we will have to take the derivative of each of these two functions, but we will only do one at a time, starting on the outside and working our way in. We can also write this a little bit more simply. Rather than calling it g of x, we can say that that g of x is just a u. So this is another one of those u substitutions where it's just easier to say f of u, excuse me. All right. Now, again, be careful with that. It's not fu, it is f of u. So we're going to let the whole function be written like this, and therefore we can take the derivative of the outside function and then the inside function without having it be so ugly. If you can see it in a little bit different way, we're still trying to take the derivative of some function, call it y, with respect to x. But the problem is there's another function inside of our outside function. So if you want to have your dy dx, well, we're going to have to take first the derivative of that outside function we're calling y with respect to the part on the inside, u. But then we're also going to have to take the derivative of the inside function with respect to what it is in terms of, which is the x. And if you notice, if we do a little simplifying here and cancel those out, we get exactly what we had. So this is a different way of writing and seeing this, what is called the chain rule. It's like we're just multiplying by a du over du. So in words, it's the derivative of y with respect to u times the derivative of u with respect to x. Before we write it in that easier u fashion, I wanted to give you a warning of what I've seen over the many years that I've been teaching calculus that students make the mistake of when getting to these chain rule compositional functions. I gave you 4 different variations of mistakes that students make, and I'll just read them to you very quickly. The first is simply forgetting to take the derivative of the inside function. They don't see it as a function inside of another, so they just take the outside and completely ignore the inside. Some take them both at the same time. They'll do the derivative of this and the derivative of that, which is also incorrect. You didn't take it individually. And then I've also seen people just keep taking the derivative and doing the derivative and doing the derivative as many times as they feel until they're like, okay, that's probably the answer. We'll see when there are multiple chains, not just 2 chains, but 3 or 4 sometimes. And you will get a little confused, but if you just start from the outside and work your way to the end carefully, neatly, then hopefully you will get to the end result, which is the correct answer. I've also seen a combination of these. So again, be careful, making sure that you understand what you're doing, why you're doing it, and for what purpose. So let's look at another format for the definition we're calling 362 that has a function raised to a power. Again, you can think of this as a function inside another function. We're going to call it a power chain for all of you loggers out there. So what we have here is a power rule first, because that is the outside function. So that would give us the n times the inside function, less 1 now. And then we need to multiply that by the, well, what haven't we taken the derivative of? We've only done the power rule. Now we need to take the derivative of the inside function. So that would be g prime of x. Right? So that is one variation of the power rule using a chain now, where there's a function on the inside and not just x to a power. Right? If we had more than one, say 3 functions, h of f of g of x, then see if you can fill this out and come up with the variation of the derivative of k prime of x. You should have come up with that. Of course, I color coordinate it for you to be able to see which functions I took the derivative of and in what order. Again, not touching anything other than those in that order. So starting from the outside, working our way in, should have taken the derivative of h first, not touching the inside. So still have our f of g of x. Then second, now that we've done that, we would take the derivative of f. Again, not touching the inside, leaving that one. And then lastly, taking the derivative of g prime of x. And sometimes you may even have like a 3x there, and you'd have to take the derivative of the 3x, which would just be 3. And that's what we wanted to look at, was what happens when there's 3 or more functions. How do we find the derivative of a compositional chain that has more than just 2 within one another? Okay, so this is the basics of this. And if you wanted to use the u here, you could say h of x is equal to f of u. And to take the derivative of that, it would be f prime of u times the derivative of u. And I put over dx just to remind you that it would have been with respect to the x. So that's it for the chain rule. Of course, it's not that easy. It will take some getting used to, and not only just being able to apply it, but actually being able to see it. You just have to get in the action and remember that practice makes, you probably said, perfect. And that's not true. It makes permanent. If you practice it poorly, it's going to end the same way. So try to practice these as best as you can, trying to comprehend the material, doing it correctly, and being nice, neat, and organized definitely helps. All right? If you need help, reach out to me, our TA, and or your classmates. Keep working hard, team. Alan, out.